Welcome to Renaissance Charge. I'm Rick Friedrich, and today we're going to talk about the following are considerations, this is a printout, pertaining to the basic level free energy systems. So this is not about the more advanced systems. This is a response to more private conversations I had about what is free energy and why self-running is not necessary in order to have free energy or over unity. It's a very specific point that's important. So before I get into it, we're going to get into loving path, selfish circuits, and loving path series. If you go down to my name, which is my channel link, the first page that opens up when you go to that link is the Selfish Circuits teaching from 2016. So there you'll find this basic idea that we're going to get into here, but this is kind of another addition to it, but it's going back to the very beginning, which does pertain to the Resonance Induction Coupler Kit 2 that we just did this year. So the idea of the selfish circuits, we're going to go from the selfish circuit being a closed loop system in which there's a loss in the system, in which there is no free energy in the normal sense or the regular understood sense of the term, which I don't think is correct, which I'll get into, because I think all energy is free energy in a sense. We'll get into that later. So we have the basic circuit here, closed path, in which there's what you expect, which I call a selfish circuit. And you can see the blow-ups of these on those pages that I mentioned. So then you have, what we've done here is expanded the energy out in a sense. We've created another path in which the environment provides more energy into the system, which is actually what happens all the time, in the sense that the environment is providing the energy. So in this particular context that we're going to get into is what happens if the electrical energy output from the free energy system is not enough to make it self-sustaining, self-running. And is that make it useless? Which is the conversation I've had with certain people, very few, but few. Some people are only interested in a self-running system. So again, what is free energy and why self-running is not necessary in order to have free energy or over unity. So as I indicated before, and again this is actually in response to specific conversations, so bear with me, I wrote it for them, so I thought I'd make a video for it for you. So as I indicated before, the whole thing comes down to a misunderstanding of the following, as well as an insistence upon one form of energy over others. Again, this was about a little bit of a controversy I had where people were dismissing a system that wasn't self-running. And there was an insistence upon free energy also being only in the context of being self-running. But in essence, they admitted that it was just their preference. So I say insistence because the statement made into a claim is merely a preference for one form of energy while others are disregarded in the matter. I say misunderstanding because two similar ideas are merged into one when they are needed to be separated. So in other words, you can have a self-running system which is free energy, but you can also have a free energy system that is not self-running. So those are things that we need to clear up. And so what are the facts of the matter? Again, this is for a basic system that is plug and play without any kind of real tuning. You're just going to get this basic output and no real self-sustaining operation. So we have a given source charge like a battery, right? Or a capacitor. Oh, I've got some printouts here. I'm going to show you. Right, so the top is a battery, the bottom is a capacitor. Get rid of this other page. Right. So now we have this source charge. A battery is considered a source charge in the conventional sense of the term. So what I'm going to be doing here is kind of going over some basic electron theory, as well as a critique of it. So I don't really hold to this view, but it's a working model that people understand things. So I'm basically going to hold the conventional theory to itself and show how it's inconsistent. It's not really inconsistent in the basic claims, it's the additional claims that we're concerned with. But I have to go over this to answer the primary question about self-running is not necessary to have free energy and clear up that problem. So we have this source charge, say a battery, or a capacitor, where we have an excess of free electrons. So in this case, on the bottom is the negative terminals, both the capacitor and the batteries. We have an excess of electrons, of free electrons, right? And on the positive plate, there's deficiency. The deficit of electrons on the positive plate, this indicates that it's charged. Now, if it's completely depleted, completely charged, then it's completely charged. So next we have the wire as a load. So this is a circuit, and the wire is the load. You consider it a dead short in application because you don't necessarily want the wire as a load. And that is also a transmission line for electrons. This gets connected from one end of the battery to the other. It could be short, could be long. So these are the facts of the first case. So we're going to look at several cases here. So charge distribution of free electrons that are pushing apart from each other. The electrons are always, their negative like polarity repels, right? So it takes place, this charge distribution of free electrons from across the battery negative terminal to the positive terminal. This happens at the rate according to the size and ease of all the conductors. Ease of movement, ease of path. We can get into superconductivity when we go into the advanced stuff with Don Smith, high frequency and resonance. But right here we're not. We're talking about what you're normally used to. So the load in this case is useless to most people. Don't disregard it. However, to others who wish to have a heated wire, like a toaster, throw out your toaster ovens that have those little wires in them, on a side note, because those are tungsten, and you don't want to be eating tungsten, which we'll be doing with every slice of bread, because it will spew out the tungsten on your bread. So get the big, thick resistor elements. Anyway, I had to throw that in. So, some people wish to have a heated wire like a toaster. This would be fine, the circuit. However, I guess I can put this up now. The wire produces the expected heat, which is like divergent energy, as well as a magnetic field around it as the load. Now again, you're not necessarily using that, but some might use it. Loosely speaking, the load is only the desired effect we pay for, and not all the effects encountered. So that's in context of what people are talking about. So think about the distinction. I'm a philosopher, I make distinctions. I'm a scientist, I have to make very careful distinctions. Most people, including the large number of people in this research at the hobbyist level, don't make philosophical distinctions enough. So, in regular conversation in life, if you get too technical, people run away from you. And I know that by experience. So you have to distinguish between loose talking and here I'm going to make the clear distinctions. So at first, these loads will exhibit a maximum intensity right at the beginning. Their maximum intensity as a side effect of electron flow. These loads will experience their phenomena, display their phenomena as a side effect, right, of electron flow. The electrons push against their like charges and distribute out, like diffusion, heading towards equilibrium. You could call it entropy in the negative sense of the term, so forth. They move from high concentration to low concentration passively. They're not being kind of forced, they're just let out of the bag. This is the opposite to when they are forced to move the other way in charging, where they are concentrated or pressed into the negative plate area. So when they are initially force charged, you're not necessarily, well, we'll talk about where the electrons come from and all that in a minute, but you're pushing the electrons down the path and pushing them into the plate, and then when you disconnect it, the capacitor battery holds that charge. So as the path is open to the positive plate, when the circuit is made complete, they have the highest pressure at that point and will accordingly reduce in pressure along the path that is opened up. So this is the highest voltage because you have the maximum difference in potential, highest concentration of electrons on the negative plate, according to the theory. And there's more to the truth than the theory says. Just have to keep reminding you of that. This isn't so much of a journey from one plate to the other, which is where it gets into a little bit more detail here. This isn't so much of a journey from one plate to the other, but a domino shuffle, like a bunch of dominoes knocking each other over, that bombard the ones next to them on the various conductors and have relatively little physical travel. So it's not as if all these electrons are going to appear over here, you know, and then there's nothing in the wire. they actually don't go very far or travel very fast. And so they will work their way into this wire, according to the theory, and influence the other ones to kind of shuffle down the line, right? Don Smith talked about that quite a bit. So, eventually, the charge across the battery will be equal or distributed so that there will be no movement and accordingly no side effect of heat and magnetism. That's if you just charge this right down to zero. In the capacitor, that's more common than in a battery, because in the battery you're usually running a load that doesn't go down to 0 volts, like 10.5 volt battery, 10.5 volts on a 12 volt battery. Your inverter will shut off at 10.5 volts. So generally that's considered fully discharged on a battery, even though it's not. Now on a side point, when we use the Renaissance charging, we can discharge our batteries down to 0 volts and not harm the batteries, provided we don't leave them sitting there. We charge them back up. But we do that in a lot of different experiments. But we also, on another side note, we have significant capacity increase from our battery charging at the lower levels, which is not found in other kinds of charging. That's why they stop it at 10.5 volts, when actually we can have a huge amount of charge left in the battery that is usable. So that's really good with lights, when you're using lights or electric vehicles that can go down to low. One of my customers is building an inverter that he's trying to get it, by my recommendation, to go down to 8 volts rather than 10.5. I'm really excited about that because we can use that more in our solar chargers than with our solar charger controllers. Anyway, enough of the side points. So once, so we're going to have this discharging, which is really just charge distribution. You have to take away in your mind the idea of consuming the energy. It's not really consuming anything. The consumption is just the lower voltage drop over time because the electrons are migrating. So you got to think in terms of charge distribution. That's why I started the second kit off with that. Basics physics of static electricity. So now, as we move there, we have a conservation of this charge in all this. That's my point. We're not losing anything. All we're doing is redistributing the charge so they're equal on both sides. And so you say, well, it's consumed because I have to push them back the other way in order to start over again. That's beside the point. Because we can do that in different ways a lot easier than you're used to, which is what we'll get into maybe here. So the electrons are merely distributed. The path, this path here, is merely a regulator of how fast and how smooth that transition was. So if we have very thin wire, it's going to take longer. And if it's long, it won't heat up as much as if it's short. So that needs to be looked at. The load, the path, is merely a regulation of how fast this battery distributes, equalizes its charge. You're not taking something out of that battery. if we recharge, and then the other issue that I'd like to get into, but I don't have time to in this video, is that it's not merely this path that's creating the effects. You have to think about what is causing the electron to maintain its charge and never run out. What is giving it that? Certainly not any kind of generator pumping energy into the electrons and they're not filling up the electrons. All you're doing with the generator is pushing the charges in one direction. You're not keeping them internally charged, if you will. And they never run out or wear out, according to the theory. So if we recharge the battery by redistributing the free electrons to the first state, like this, and add an additional element in series with the wire circuit, we can observe the same thing. Go on to the next point. Well, I'll hold it up. So here we have the load in addition to the wire. The wire is still a load, but now we have an additional element which is going to be called the load. It's more of, like I said, the loosely defined term load, because it's the only load that people care about in most cases. So in this case, we're adding an element in series with the wire circuit that we just had. It was just a wire, and now we're adding a load. And we can observe the same things happening as in the first example, charge distribution. And there's no difference. The same amount of electrons are going to pass through and discharge this battery all the same. Just because we have a desired load here doesn't mean we're spending more energy, because the load isn't consuming the energy. That's what you have to get out of your mind. In this case, we have a carbon resistor. The negative charges distribute as in the first case, and the resistor heats up more than the wire, as it is more concentrated, a more concentrated conductor. I'm not going to get into the specifics, but this heats up this load as a resistor. However, the resistor does not produce the same magnetism as a wire-wound one would. The effects would be differing amounts of magnetism in either case. So if I had a wire-wound resistor, it would be different. But the whole point is, the same amount of energy is going through the whole entire circuit, then is leaving the battery, positive terminal, or negative terminal to the positive terminal, in either case. In the third example, we replace the resistor, so really the third example could be the fourth example, because if we did a wire-wound resistor, that would be actually a third example. So we're going to replace the resistor with an inductor, or a transformer. Now I could have drawn another diagram, but just leave it at that. So now you have either this is the primary of the transformer, or it's an inductor by itself. So charge distribution again takes place over time. It's going to be a different kind of time this time, but the same amount of energy will be used in the process. No additional energy, no matter what we do here. It's merely a matter of time, the different kinds of loads and resistances and so forth we place across there. And there's a different amount of output we can get in all these various different scenarios, which is contrary to what you think about with conventional theory. It wants to instill in you the lie over and over and over again that no matter what you put along this path, you're going to have, because of the same amount of charge distribution, your output is always going to add up to a certain predefined claim of what can be done in the various forms of energy outputs, which again are contradictory to experience. So, let's go on. So in this case, and according to the amount of inductance and turns of the inductor, etc., while the pressure is initially highest, the flow is the lowest at the start, which we don't need to get into. But I just wanted to mention that brief, that before we were going to have the highest rate of flow at the start because we had the highest pressure. Here we have very much, now again, I want to say too, current flows in this direction in the measurements and understanding, but electron flows in this direction, which is quite confusing to people's minds. Anyway, so initially we would have started out without this regular load. We would have the highest pressure and movement immediately, but now because we have an inductor there, we have resistance to the rapid flow initially, and we see it later on, which you can get into on your own time and study that. So, unlike the resistor, a significant amount of magnetism is produced in the load than in the first and second case. The second case being the resistor, the first case being just the wire. Now some people think that you have the same amount of magnetism with or without turning any loops, but that is not the case. The effects of all the different fields, because there's several, is different as we add more wire loops. And then you have to ask yourself, where is the magnetism coming from? And that's a very important question to answer. It doesn't matter where it necessarily, well, it does in a lot of application and research, but if you observe effects and you go by your observation, then you don't necessarily need to know the why of things or how it happens. So in this, so again, there's a greater amount of magnetism produced than what you see in the whole wire itself, by itself, or the wire in the resistor. It's not merely more concentrated. And when they mention of the Newman motor as an example of that, you can look at some of his videos of massive motor, miles and miles of wire, and very little input energy, and a very massive electric field produced. And so obviously it's not the same amount of electric field that you would have on just a short loop of wire. that would just discharge the batteries really quickly too, by the way. So in this third case, that magnetism produced can push or pull a magnet or iron to move a motor greater than the entire length of the single wire could in the first case, because there's a greater amount of magnetism created with each loop of wire. That's why you can see some of our motors in that we've made massive amounts, nowhere near the size of Newman's motors, because that is actually practically, it's unnecessary, and it's a waste of cost of money on wire. But it does prove the point that I'm making here. So, in addition to this extra side effect, now this is a second point about adding the inductor here. We can run a motor, right? Now this is so far all conventional knowledge. However, what is not conventional is the more turns that I just mentioned creates more magnetism, which creates a greater and greater potential effect, side effect, all with the same amount of electron flow, right? You have to keep that constantly in mind. So in conventional theory, it wouldn't matter how many turns you have of wire. In their mind, you have the same amount only possible from this process, from this battery, right? All you're doing in their mind is changing the rate of flow. What I'm saying is, yes, that's true, you're changing the rate of flow, but you're also creating a difference in the kinds of effects that you can have if you consider all of them carefully, like they should be doing. So, now we can also, in addition to this additional flow of electrons, in addition to producing magnetism, we can also create electrical flow in a side circuit, which is getting back to our... Oh, actually, before we get into that, we'll talk about the light. So there's your bulb instead of a resistor. Now we can have the same amount of heat in the bulb as the resistor, but we have light as well. So you have to realize that distinction. You're not pulling more energy from the bulb with less heat in a bulb. You're still creating the same amount of heat, more or less. I'm speaking in kind of loose terms. You won't necessarily, well, it's, anyway, in general I'm speaking that way. But the point is, you could have the same amount of heat produced and light at the same time, and your heat in your wire is still the same as you would with a resistor or just the bare wire. Again, the same amount of electron flow in the circuit. So now we go into the motor again. We see the loving path circuit. So here we have the conventional closed loop. Now we're going into the loving paths. We've opened it up to another loop. Now again, the electrons still flow from this negative. Now usually we have it the other way around on this side. That's fine. Anyway, the net electrons still flow from here to here. Right? They're not going to flow this way. Right? This could be more like the PNP transistor circuit, a little bit different. Anyway, electrons still flow through the motor here and complete this path. But now we've opened up the circuit to charge another battery. So this ends up charging this battery by influence of this inductor. which is a coil to run a motor. So now what we have is a gain of energy beyond what we saw with the motor. How is that possible? Well, how is life possible? How are many things possible? We don't always know. We don't always have to know, I should say. Now the question is, where was I here? So, now we've created a side effect of charging another battery. So the inductor itself is allowing for an opportunity beyond merely pushing a motor and beyond merely being a resistive heater. So it has three different things in one. The three different potential outputs, but they don't add up to the charge conservation law. Doesn't apply in this context like everyone wants to make you think. You go to school, your professors are going to tell you in all the intricate detail how much energy it takes to produce heat at given voltages, based, calculating with the ambient environment in a carefully controlled system. How much energy does it take to produce BTUs or whatever? How much does it take to produce torque? Horsepower, 746 watts to produce 1 horsepower. And all this, that's all you can do, right? So let's go and think about that. But now we're adding this third element, besides the heat, we're adding charging. That's not supposed to be there. So how do we account for this extra side effect? So we can produce or influence additional electric to flow in a side circuit across the coil to another charging body. So this is what we call the single body and many body. So this becomes a second body. This is a many body circuit. So this is a complete circuit in itself. It still doesn't change. This running this way or this way doesn't change the fact that adding this second body will give you additional output. So technically speaking, in a closed loop, closed environment, all those things are pretty much predictable. However, we're never in a closed environment, ever. It doesn't matter. We always have an impulse, for example. We never have DC by itself. There's always an impulse before, and at the end, when we're pulsing, we're turning on a switch and turning it off. And we're always being fed by the environment some way or another, which is more mysterious part of it, but we can still observe all these things and throw away the useless theories. And I'm talking about the specific claims that you cannot get any more out than the operator input. How much does the operator input into a solar panel? Right? So, we can call that second parallel body a cul-de-sac that is not part of the main flow of electrons from the battery negative terminal to the positive terminal. All right, we've added another loop here, but we're not paying for anything there on that loop. So cul-de-sac, some people live on a cul-de-sac where there's only one entrance into the little area, the street where these houses are on, and so the main traffic flows on the outer street and nothing is coming into that, so it's a cul-de-sac. So it's the second body, it's not part of the first. In that case, the second body has its own set of electrons that move in an opposite direction and also opposite phase to charge another battery or capacitor, or whatever load it's connected to. The same amount of electrons pass through the primary of a transformer in this case, and the same amount of magnetism is produced to move a motor as mentioned. But in this case, more work was done without reducing the other forms or side effects. In fact, we can enhance them. So I showed this many times for many, many years. The fan circuit, taking exact fan, showing the CFMs on it, and then simply adding a diode inside there, moving a diode around, adding some wires to come out to charge a battery. The fan sped up, the input energy decreased slightly, and now I'm charging another battery with the same CFMs. So where that doesn't make any sense, because I have the same amount of heat, I've got the same amount of torque, actually a little bit more, and yet that's supposed to be, the conservation of energy is supposed to be displayed in that, whether in a combination of heat and torque. But in fact, I have added a third element of extra charge. Where is that coming from? Well, it's its own loop. But how is that charging the other battery? It doesn't make sense. Because they're not showing you that circuit in your physics class. So therefore they're creating a smaller reality for you and claiming it's the all of reality. So again, we have an additional side effect, additional form of energy. More work is done than just the motor and heat. So these are all foundational things you have to come to grips with, otherwise there's no real form of free energy other than that which is provided from the obvious environment of the solar and wind or hydro. It is assumed that all motors will run at least 100%, will run less than 100% efficiency in relation to this charge distribution process. If it takes 746 watts to produce 1 horsepower, then all motors will take more watts to produce 1 horsepower. It is also assumed that the difference above 746 watts will be in the form of producing heat, and that any additional loads combined, like heat, will be factored into the total amount of possible work done that can be done from this distribution of charges flowing through the entire circuit. So in this case that I just mentioned, we got more energy, useful energy out than was supposedly possible. So this is where there are more details than what they're telling you. And this is all primary knowledge. This is all something that should be taught right from the beginning. This shouldn't be waited till you get past college level to learn this stuff. Because up until college level, that's what you're taught. So, the heat losses in the lines and motor require more watts in order to reach the desired 1 horsepower, and all energy is conserved and accounted for. So, but if the motor is also a transformer that can influence a secondary circuit to charge a battery while affecting the same amount of work done in the circuit as before, how can we account for the difference in the total work done with the same amount of charge distribution taking place in the primary battery. We have 1 horsepower and with perhaps 1,000 watts input, along with the already factored heat produced. But how can we have a significant amount of additional charging that takes place in a secondary battery? Because it's a loving path, right? And the environment is adding the energy in. This is what we call free energy because it's not part of the regular flow and is not acknowledged conventionally. It's a big bad word. And again, some of you won't be listening to me, and you'll hear me say free energy, and you'll say, oh, you shouldn't use that word, blah, blah, blah. And I'm saying, I'm qualifying this, all systems are free energy. It's just in the casual sense of the term, people are thinking about not paying for that energy. Like once you pay for the solar panel, you're collecting this energy for free without adding any operator input. So that's the context they use it in. And again, it's not supposed to be possible in this context, conventionally speaking. The total amount of work done is greater than what lower level science says is possible, because lower level science, that is up to the college level, considers, in this case, charge distribution in the primary battery It considers that in the primary battery to be the only source of energy input, while also considering the loads as consuming that energy rather than being a side effect of the flow. So they speak loosely to you and they make you think that the load, this motor coil, is consuming the energy in the battery. That's how the average person thinks about it. That there's a loss in the battery that has got to be refilled like gasoline in a car. But it's not. It's merely pushing the electrons back to the negative plate. But it's removing electrons from the positive plate at the same time. So you have to think about that. So, the question of where any of this energy is ultimately coming from is different from the fact that more work is being done than what is assumed to be possible with conventional science. Remember those distinctions, that distinction. This extra energy is called free energy, even though all energy is free in the proper sense of the term. So, returning now to the primary point brought up at the beginning. Admitting that the several different loads being run we are creating heat, we are creating motor action, and we're creating charging action. So remember, admitting that the several different loads being run can add up to more than what is conventionally possible when considering the distribution of charge in a source battery cycle. Why should anyone insist upon the electrical energy load to be greater than unity, or more electrical energy be produced than what is supposed to happen in regular charge distribution, in order to demonstrate free energy, when in fact there would be less electrical energy produced than the supposed input? While the other forms of energy, such as mechanical, heat, energy combined, would be greater than the total input. So here we have a little graph here. It's a long sentence. I encourage you to play it back. So here's the input, that we're going to look at here. Consider this in terms of 10 units of energy combined to form the total amount equal to the total amount of input energy in the total charge distribution. So this should help. So we've got 10 units here representing unity. And now, if the electrical output showing here is somewhere between like 2 units and say 99, here we have got 9 units, but say it was 99. Just want to make a distinction here. So if we only had, 2 units extra, but we had the mechanical amount of energy produced was say 8 units, we'll call it 80% efficiency, and then we've got 2 units worth of heat produced. So if we had only 2 more units of energy produced in electrical, we'd be right there at unity, plus we have we would be considered 100% efficiency if we had electrical output of 2 units, because people are disregarding the 2 units of heat. And suddenly they wouldn't be measuring heat anymore. They'd be forgetting about the heat. They'd be saying, oh yeah, well you got conservation of energy there. So what happens if we got 3 units there, or 4, or 5, or 6, or 7, 8, 9, 9.9 units, plus mechanical energy? This is kind of the easier way to look at it. So, this is not to say that we cannot produce more than unity in electrical output. Okay, this is at the basic level where people haven't done any tuning. They've got maybe garbage batteries they're working with the motor systems, and they're not. I'm just trying to address the issue that there is free energy without self-sustaining, or without the electrical being produced equal to that which is supposedly being consumed. So now we are looking only here at correcting a misunderstanding in regards to what free energy is in the general understanding. We can in fact create unlimited electrical energy with appropriate additions or modifications, as we begin to see with the miles of wire like Newman's motors, as I mentioned, or the massive batteries charging like Bedini's monopole system, and much more with Don Smith's high frequency resonance systems. Of course, we can also convert more of the mechanical energy from the motor in this case. So if we then pull some mechanical energy from, say, here, and make it electrical energy with a generator, we can add more electrical energy than the input energy and make self-sustaining. So let's talk about that. So we can do this enough to keep the input continuously charged. In order to keep the input charged while it's supposedly powering those loads, it will take more than these 10 units of electrical energy making up the full unit, because it doesn't like to do that. It doesn't like to receive charge and give charge out at the same time. And that we're talking primarily here about lead acid batteries, is less so with capacitors and lithium batteries, for example. I'm not a proponent of lithium batteries, but they do give you better advantage in that case. This brings me to the last point. If we are using this basic free energy system that needs to convert some of the mechanical energy to electrical to keep the whole thing self-running, then is it not acceptable to initially create more charge flow in the primary source and less total usable energy output? That is, considering that most of the output is going to sustain the system. What if we do this and have 10%, 25%, or 50% of the usable mechanical energy or other output continuously than what we would have if we just ran a similar motor from the battery and discharged as normally expected? So let me say that a little bit clearer. So if we have normally it taking 1,000 watts to run this motor off of this battery, and after we run it and discharge it, after a while the battery is discharged. So taking 1,000 watts to run this. So what if we have a basic system that produces electrical energy, and say this one, say, doesn't fully charge up at the rate that this discharges, right? This is what some people will experience, depending on various factors or what system they're running, how good the system is, and so forth. So say now, in order to make this self-running, we have to take some of the mechanical energy with a generator and add to this to keep this all running. So in that case, we're going to have to produce a bigger system in order to make it self-sustaining. So is that totally unacceptable? That's what some people would have you believe. I haven't heard too much people on the internet say that. Once in a while you get some people. So the point is, even if you have to pull some of the mechanical energy and fill up this input battery, keep it charged along with this battery, then you should be fine with that. And it's like calling that still free energy, if you insist upon free energy being only self-sustaining. So we see the 2 points clarified here. Practical free energy can be experienced without self-running when we add up all the outputs. There's much confusion about how we add that up, as well as in saying that the effects in the loads consume the input energy. If we produce, number 2, if we produce supposedly excess energy in a free energy system, then we may be able to convert enough of the output to make it self-sustaining, even if we lose much in the process. That goes beyond the basic level most people, doing that also requires extra parts and precision processes that go beyond the basic level most people are committed to in this pursuit. Right? The practical consideration for people in this is whether they want to go to the trouble of doing that on a small system when they are still paying for energy for the most part, in their homes. So if you had, this is, I think, in my conversations with people, how much trouble are you going to go on a small system if you just simply want to be a plug and play person and just run something how much trouble you want to go to on a small system to try and get it all self-running and regulated. Because the other factor is too, is you could have a system produce too much charge. So now you've got to regulate it so it's not overcharging the battery, right? That's, most people don't think about. That's the stuff that I have to deal with in various systems. Too much energy. So most people are limited to plug and play mentality. And over my years of watching people in free energy, I've watched how people were a lot more geared to thinking and experimenting, and now it has changed drastically. People are not capable of doing very much at all anymore. They're just mesmerized through the internet, through watching TV and the music and all this different stuff that has made them down to a drone level knee-jerk reaction. And I've seen myself degrade in that way, so I'm not pointing fingers. I'm not saying that I'm useless at this point, but exposure to all these things have made people pretty much a plug-and-play mentality. And especially men, the majority of you don't read instructions, don't want to take the time to think, you just want to plug it in. And so I'm kind of catering to that by saying this in this video. So most people don't want to, who are plug-and-play mentality, don't want to bother with messing around and try and get it self-sustaining. If they calculate the losses in trying to do this, recycling of the charges compared with running several different outputs from less input, they may decide to leave it that way. So if they really do the math, which unfortunately people who are on the plug and play mentality don't do the math. Like for example, people don't buy my battery chargers because they don't think of changing a battery until they're in a desperate state. The battery doesn't turn over the car, the starter, and so then they run and grab a battery. If they did maintenance, like they don't do with their health generally either, then they would actually win the race like the tortoise that wins the race in the long run. But if you're trying to just put together something and you think about it, so like what I've done a lot of times is run the output into another system. So I'll run one motor system into another motor, into another motor, into another motor, as I've mentioned. I've very rarely demonstrated that. But why try and necessarily rotate a battery around, which we do have that swapping circuit. And when we get the new boards made up, we'll probably have that. Won't be for many months before we can get to it. We'll make the new circuit board up with the nano board, and we'll put that right in on the board itself, the ability to rotate right in there, all the circuit. So but trying to rotate a battery around and keep that all exactly maintained, or trying to force the charges back into the primary battery is more difficult than it's worth for most people. If you think about it, if you're taking so much power from the grid, if you're connected to the grid, and you're producing a load plus a free load on top of that, then you're doubling your output from your input or more. So you've got a mechanical load and you've got a charging load, and so instead of taking something off the mechanical and trying to put that all in input, you can just have two outputs. So it's really more efficient than pulling that from the wall or taking it away from the wall. If you're already using the grid, then pulling from the grid to the primary sort of trigger current, and you get two outputs with that. The second output you'd have had to pull from the wall anyway. So now, if you're charging up another battery, for example, and running a load off of that, then it's going to be a gain over than trying to make this whole thing self-running, if you're at that basic level. So I'm just trying to solve various problems for people because I have all the phone calls and I know what people are at. So this is kind of explaining how these things work, as well as explaining what your options are. And I know the way people are. I know how you guys are. Many of you call, what do I do? Typical for men to ask. That's why women are good at giving the answers. Because typically, I'm not being sexist here, it's just typical. People want to be told what to do. And so I'm just telling you some of the options, because I have these kind of phone calls, which now I'll direct people to the specific video to answer. So this leads you then to more advanced or intermediate subjects. As you can imagine, this will lead into the second stage process as well, and all the third stage process in this Loving Paths series. And it's expandable. You have to have these basic ideas though. However you define them, I don't care. You have to have these basic ideas in order to move on to the other stuff. So it depends on how much commitment you want to put into this learning process. But I've tried to provide a full spectrum of learning and all the kits where you can start with basic Loving Paths concept, which is plug and play. You can have instant results, which thousands, over 10,000 people have bought these products over the last 17, 18 years from me, and have been largely satisfied, even at the basic level. Now some people want more advanced stuff to be plug and play, and that's another whole subject matter to get into. But if you go through this stuff, you can learn. Some people have been asking, one recent comment I got back to, where do I start, Rick? Where do I give us the books to read? There is no books. There is no primer in the sense of electronics course going from beginning to end. When I first met Bearden in I think 2004 at his home, I asked him that question, well, where do I begin? Because I was at the beginning with all this. And he said, there is no such thing. And I was like hoping he could, do it, provide it. But unfortunately, the only thing is for people to go through the conventional teaching and then unlearn it. So what I try to do is, because I'm not competent enough to write such a book, this stuff is not my expertise, this is not my, this is kind of like, it's become my main work, but it's not really my main learning. Physics isn't my specialty. So I wouldn't be the one to write the book either, but I at least am pointing out things that are wrong and so forth. So that's where I'll end it. Thanks for watching.